Okay, so let us start now. In the meantime, maybe some of your friends will join. So, if you recall our discussion in the last class, we were discussing about the Hall timing diagram of the IC engine, in which we have discussed that IVO, IVC, EVO, EVC, that is intake valve opening, exhaust valve, sorry, intake valve closing, exhaust valve opening, and exhaust valve closing. It doesn't, all these things not take place at the top dead center or bottom dead center. In fact, it is, in fact, it takes place slightly before and after the bottom dead center and the top dead center. So just to recap it little bit, so IBO takes place just before the top dead center and it closes after the bottom dead center. Similarly, the exhaust valve opens just before the bottom dead center and it closes after the top dead center. And then we also discussed one of the important things, that for the certain crank angle, the intake valve and the exhaust valve both are in open condition, and that condition is called valve overlapping. Okay, so this, how much away or how much after the bottom dead center or before the bottom dead center, or after the top dead center or before the top dead center, it depends upon the optimization. Then we also discuss that, then we raise some of the question based on our last class discussion, that whether all these four parameters regarding IBO, IBC, EVO, EBC, is it constant parameter? Constant parameter, it means for a given engine, whether these all four parameters is a fixed parameter irrespective of the engine speed, or it can be vary. First of all, what should be? Whether it should be the fixed parameter or it should be variable parameter. Then we can find it out that if it is like that, then what is the current status in the production technology or in the current technology in the automotive industry. So that these are the things we tried, questions we tried to raise it in the last class, and in this class we'll try to answer it all these things. You also raised some of the questions that I asked you to hold it for the next class, and it means it's today class. We'll try to address some of the questions that you raised in the last class also. As far as the CI engine is concerned, the valve events also takes place is a similar like of IC SI engine. It's only the difference is that the crank angle, the value of the crank angle, it may change. And instead of the spark timing, here in the CI engine, you will get the what is called injection pressure. Other than that, the most of the things is the same. Now, what we are going to discuss now, that, or we will try to find it out, that whether the valve timing event, how the valve event timing affects the gas exchange process. Okay, because gas exchange process, this IBO, IBC, EBO, EBC, it affects the engine's volumetric efficiency, and in fact it also affects the thermal efficiency, power output, and then the residual gas in the exhaust gas. So let us discuss that how it all these things is going to be. So let us first of all discuss mainly with intake valve opening. Okay, intake valve opening. If you see this image in which the piston is moving up from bottom dead center to the top dead center during the exhaust stroke, and these red points, it is showing it is a exhaust product. And if you can see in this here, it means we are piston is moving from the top dead center to the bottom dead center. Okay, and then as we discussed in the last in the previous slides, that intake valve takes place just before the top dead center. So it means that this is your top dead center. So it means intake valve, it may open or it opens just before the top dead center. So what we are going to do, we are going to discuss two extreme condition. One, when engine is running at the high speed, and another when engine is running at the low speed. At both speed conditions, okay, let us suppose the engine is running at the low speed. Then what will happen if the intake valve opens closer to the top dead center, that is represented by the blue color, and other than another case, that what will happen if the intake valve opens too early or before too early. Am I, that is representing here it with the red line, red points. So that two situations at one speed, then they will consider the when engine is running at higher speed, and then we will again discuss about these two conditions. Okay, and then it is going to be clear that whether the IVO has some effect on the low speed and the high speed, and then intermediately it is like we can interpolate the situation. Okay. So now, first case, let us assume that engine is running at low speed. Okay, low speed, it means the idling speed something around 1000 or 1200 RPM. And you have set the IBO too early. It means it is something around, let us example I'm taking as it is around 40 degree or 60 degree before top dead center, but it is just the example numerical value I'm taking it. Or we can, in general, we can say early IBO or late opening. So what is going to be, piston is moving up during the exhaust stroke. Okay, can anyone tell me that what would be the approximate pressure inside the combustion chamber during the exhaust stroke? At this stage, when the exhaust stroke is going on, at that time, your exhaust valve will be in the open condition. Okay. So when piston is moving up during the exhaust stroke, what would be the approximate pressure inside the combustion chamber? Anyone?
Near about atmospheric pressure.
Very good. So the pressure inside the combustion chamber is at about atmospheric pressure. In the exhaust manifold, it is open to atmosphere. So it is also at the atmospheric pressure, but because of the action of the piston, okay, the exhaust product inside the combustion chamber, it is forced to atmosphere through the exhaust valve, and engine is running at low speed. In that condition, let us suppose when piston is reached at about 40 to 60 degree, or at the 50 to 60 degree before top dead center, that we are terming it as a early IVO. At that time, your intake valve is also going to be open, or IVO is taking place, and piston is running at, engine is running at low speed. In that condition, what would be the position of the throttle position? It is going to be what? Too open, or it is going to be almost closed, or very slightly opened. throttle. If it is a spark ignition engine, then obviously it has a throttle in the intake manifold, and the engine is running at low speed. If you are talking about 1000, 1200 or 1500 rpm, at that condition, what will be the throttle position? Is it too open or it is slightly open? Because accordingly it will determine that what is the pressure in the downstream of the throttle. So since engine is running at low speed, okay, the throttle opening is very less, and that's the way the engine. That's the way that it means engine is running at low speed. So it means the the pressure in the downstream of the throttle, okay, here it is lower than the atmospheric pressure. So at the time when the intake valve is open, at that time the pressure inside the combustion chamber is about atmospheric pressure, and here it is lower than the atmospheric pressure. Then there will be a temperature pressure gradient, and then there is a probability or there is a high chance that the exhaust product, part of the exhaust product, will enter into the intake manifold. And then during the intake stroke, when piston will move from the top dead center to the bottom dead center, then a mixture of, then these residual gases or these are the exhaust products will come into the combustion chamber. So what it is going to be happen, it is going to dilute the air fuel ratio, and engine is running at low speed, and it is dilution is going to be takes place. So it is going to change the air fuel ratio and it may affect the engine performance. So but we can conclude in that way that when the engine is running at low speed and the intake valve is going to be opened too early, then there is a probability that the exhaust product will move, it will enter into the intake manifold, and it will dilute the air fuel mixture. So that is not a conducive situation. So what it is better, or we can say that when engine is running at low speed, then it is always beneficial to open the intake valve closer to the top dead center, so that the recirculation of the exhaust into the intake manifold can be minimized. So it means it is always good or to open the IQ takes place closer to the top dead center. Okay, obviously before the top dead center, closer to the top dead center, and when engine is running at low speed. So that's the one situation. Now, when engine is running at high speed, it means your throttle is considerably open, and then the pressure in the downstream of the throttle, obviously it is not be at the atmospheric pressure, but it is very close to that. And since engine is running at high speed, when during the exhaust stroke, the momentum of the air fuel mixture will be towards the exhaust manifold. So, and when engine is running at high speed, in terms of the time, in terms of the, it has a very less time to finish the event. So what it is in what we can do, we can open the intake valve even little earlier than the little earlier or before or before the piston reaches at the top dead center, too early, so that we can at the time when the piston is coming down, at that time the intake valve should be completely open in condition, and the exhaust recirculation, the chances or probability of the exhaust recirculation will be slightly or very less, because the pressure in the manifold is also very high, and the most of the exhaust gas will go out from the exhaust manifold because of the high momentum also. So when engine is running at low speed, then I view with these discussions we can conclude that when engine is running at low speed, then I view should take place closer to the top dead center. When engine is running at high speed, then I view should take place earlier. Obviously, there is no point to delay the IVO after the top dead center in any condition, because if you do that like that, then what will happen, it is you are intentionally isolating the intake manifold from the cylinder, and that it means the gas exchange process you are delaying it, and then it will affect the volumetric efficiency and you will get the lower volumetric efficiency. So there is no case that the IVU should take place after the top dead center, yeah, after the top dead center or before the top dead center, depending upon the engine speed, it can be fixed. And if these two conditions are the extreme conditions, then the in between the speeds, it can vary in between these two conditions. And in that way, we can set the IVU, that is intake valve opening condition.
So can you please explain this high speed case? Why IVO should take place early?
Yeah. So at the high speed, what does it mean at high speed? High speed, it means the intake valve is considerably open condition. It means the intake manifold pressure or the pressure in downstream of the throttle, it is um, more than the what it is when the engine is running at lower speed, or we can say it is um, very close to the atmospheric pressure, but obviously it will be the lower than that. So the first thing is that the pressure difference or gradient will be less in the combustion chamber and the intake manifold. That's first things. The second thing is that when piston is moving, the engine is running at the high speed during the exhaust stroke. The intake exhaust manifold is in open condition. The momentum of the exhaust or the direction or momentum of the exhaust product will be towards the exhaust manifold. And the third thing is that since engine is running at high speed, okay, so in terms of the time, it has a very less time to complete the complete the one stroke. If because when it initiates the opening, when the intake valve it starts opening, it takes some time to be completely closed, opened. So it is, and we have a problem with that. We have a time problem also, because engine is running in time problem in sense. Let us suppose the intake stroke has a duration of around 220-degree crank angle. Once the engine is running at 1000 rpm, then you can find it out that how much time it will take in cover of 220 crank angle. And once engine is running at, let's suppose, at 4000 rpm, then obviously the time is going to be reduced too much. So but at higher speed we need to maximize the volumetric efficiency also. So therefore it is always beneficial to open the intake valve earlier, because so that we can have a more time for the at the time when the piston is coming down, then the intake valve is completely in open condition, and since it is considerably opened conditions, throttle is considerably open, the pressure gradient is very less, therefore the probability of recirculating of the exhaust gas into the manifold will be very less, and that's why the intake valve is taking place earlier in when engine is running at high speed. Is it clear or
Okay,
still
sir.
there? Yeah. So what we can see here, that intake valve has is a not a fixed parameter. Okay, we can see that there is some problem, or it's not like that. There is a one fixed value of IVO is going to satisfy the all operating range of the engine. Okay, is there any question here? Then otherwise we'll move to the another question, another IBC. Okay, so if there is no questions, then what about the IBC, intake valve closing? So in our general discussion, we have discussed that intake valve closed after the bottom dead center. Okay, and it is in the range of 40 to 60 degree. Okay, it can be from bottom dead center to 40 to 60-degree crank angle after bottom dead center. That is what we have discussed in our general discussion, that IBC takes place within that range. So where IBC takes place? Now remember at this point that, yeah, one important thing, sorry, I just forget to tell you in the IVO, that this first point, okay, that IVO is not only as is indicating the beginning of the intake process, okay, but also it is initiating the valve overlap period. Because when piston is moving upward in the, during the exhaust stroke, at that time exhaust valve is open condition, okay, and when intake valve is going to be open, even when piston is not reached at the top dead center, at that condition both valve will be in the open condition, and that is what we call overlap period. And therefore that point is very important, that IVO is not only the beginning of the intake process, but it is also the beginning of the valve overlap period. Okay. Now let us come to the exhaust valve closing. That is always takes place after the bottom dead center. Then where we should close it. Now after the bottom dead center, the piston is moving up. In that piston is moving up, and intake valve is in open condition. So now where we should close it. when piston is now at this point, piston is moving up, this valve is closed, this valve is in open condition. Okay. And why, first of all, why it is not closed at the bottom dead center, but after the bottom dead center? It is only because that when the piston is coming down from top dead center to the bottom dead center during the intake stroke, then the air is coming from the intake manifold through the intake manifold that has a certain momentum. So if you close immediately at the bottom dead center, okay, then what will happen, that in fact there is a chance that if the intake valve is closed after the bottom dead center, okay, even though piston is moving up now, but since the momentum of the air is coming down, so there is a probability that we can trap more amount of the air inside the combustion chamber even when piston is moving up because of the momentum of the incoming air. And then our aim, you know that our aim is to maximize the amount of the air inside the combustion chamber or maximize the volumetric efficiency. And therefore, the IVC always takes place after the bottom dead center. But the question is where it is. Is it 5 to 10 degree after bottom dead center? It is more than the 40 to 60 degree after bottom dead center. It all depends upon. See, the thing is, our main motive is to maximize the volumetric efficiency. So when piston is moving up, we can delay the IVC as long as the pressure inside the combustion chamber is lower or about equal to the intake manifold. Once again, we can delay the IVC and we can fix the IVC at that point. Ideally, we should fix the IVC at a point at which the pressure inside the combustion chamber and the intake manifold is going to be equal. Because even if you are delaying that after that point, then what will happen? Then backflow will take place. And the air will move out from the combustion chamber to the intake manifold. And that is what we require. And if you are closing beyond that, below that, it means you have a chance to maximize the volumetric efficiency, but you are not utilizing it. So therefore, we should fix the IVC at a point where the pressure inside the combustion chamber and the intake manifold is just about to equal. And that is what we can determine the IVC. So when engine is running at low speed, okay, low speed, then as soon as the piston reaches at the bottom dead center, and then what happens at that point itself, almost when the piston is moved reach at the bottom dead center or slightly above beyond the bottom dead center, the pressure inside the combustion chamber is almost going to be equal to the intake manifold, and it is always good to fix the IVO closer to the bottom dead center, because if you delay beyond that, then the pressure inside piston is moving up in this direction from the top BDC to the top dead center. Pressure inside the combustion chamber will be increased, and then it will push back the gas to the intake manifold. So at lower speed, the IVC should be closer to the bottom dead center, because the very close to the bottom dead center, the pressure inside the combustion chamber will be almost equal to the intake manifold condition. When engine is running at high speed, okay, we can delay the IVC even beyond the BDC more than the this point, because of the higher momentum through which the air is coming at this point. Because at the higher speed we have a higher momentum of the incoming air. So even if we have a chance, or we have a flexibility to delay the IVC in order to maximize the volumetric efficiency, and then it can be closed, because even if piston is moving up, there will be very less chance that the air will be backflow because of the higher momentum of the air. So delaying the IVC causes the volumetric efficiency increase at the higher speed because of the higher momentum of the incoming air. At the lower speed, where the intake manifold and the cylinder pressure are equal at bottom dead center, some fresh charge will be pushed back into the intake manifold prior to the IVC. So IVC has to be closer to the bottom dead center at lower speed, and slightly away from the late IVC at the higher speed. In that way, we can fix it. But the thumb rule is that IVC at any condition, IVC should be fixed in such a way that where the pressure inside the combustion chamber is just about to equal to the intake manifold. Okay. Similarly, let us discuss about the exhaust valve opening condition. Exhaust valve open condition. So now the things is now what we can consider it here, that during the compression stroke, okay, when the piston was moving from the bottom dead center to the top dead center, then before the piston reaches at the top dead center, just before that, okay, a spark is taking place. Okay, that spark timing itself is a variable parameter that can vary from 5 degree before top dead center to around 40 degree before top dead center. Okay, so when during the compression stroke, when piston is moving from the bottom dead center to the top dead center, before the piston reaches at the top dead center, a spark is going to be takes place. And then after some time, delay time, the combustion is going to be start. Okay. And the pressure and temperature inside the combustion chamber will be increased, and it will push back the piston down, and then piston will move. That will be our expansion stroke, and piston will move from the top dead center to the bottom dead center. And that is what our power stroke. Okay. Now where we should open it? Should we open it where? Now there are 2 points of the things here. Now if you open EVO at a point where the pressure is above, pressure is slightly, pressure is more, it means, let us suppose I am saying 7-8 bar or something like that, even more than that. Okay. Then what will happen at that time? So if the IVO is taking place early, at that time the pressure inside the combustion chamber will be obviously high. And at that time, if the exhaust valve is going to be open, the pressure gradient between the combustion chamber and the exhaust manifold will be very high, and most of the exhaust product will be go out from the combustion chamber. So the piston has to do less work when it will move up during the exhaust stroke, and that's where we can have a lower pumping loss. But what is the demerit here? That you are opening the exhaust valve too early, and then it means effectively you are reducing the expansion ratio. That pressure, it may contribute to your power output. If the IBU is taking place too early, it means you are compromising with the power output, but you are reducing the pumping loss during the exhaust stroke. So there are the two, one side I'm getting gain, another side I'm a loss. So what I should do? We need to find a point where we can neutralize the things. So the thumb rule in opening the IVO is like that. We should open the EVO in such a way that when piston reaches at the bottom dead center, at that time, the pressure inside the combustion chamber is about to atmospheric pressure. If you open the exhaust valve too close to the bottom dead center, and then what will happen? Then even when piston will move up from after the bottom dead center, if the pressure is more than the atmospheric pressure, then the piston has to do a lot of work. That is a negative work done. Piston has to do the work on the gas to flash out from the combustion chamber to the exhaust manifold. Therefore, it has to do a lot of work, and it will increase the pumping loss, and that is the negative work done. So the thumb rule in fixing the EVO, exhaust valve opening, in such a way that when piston is reached at about the bottom dead, we should find the EVO at such a point that when piston is reached at the bottom dead center, at that point the pressure inside the combustion chamber is about to bottom dead center, about to atmospheric condition. So at the lower speed, and in that way we can find it out that at the lower speed, when there is a less amount of the fuel and air, okay, the whatever the combustion is going to be takes place, it is going to be takes place in the 40 to 60 degree crank angle after the bottom dead center. After that, the pressure and temperature inside the combustion chamber is not going to contribute any significant or any significant power output. In that condition, even if you are delaying the EVO, then what will happen? We will not able to get the benefits of the pressure gradient between the combustion chamber and the exhaust manifold. And then piston has to do the work to remove the exhaust gas. So it is always been is good to open the EVO earlier than the IBO should takes place early at the lower speed. At the higher speed, when again we have a play with the time and there is a more pressure and temperature. If the EBO is taking place too early, then it might then at that time the pressure will be even more than that, and then you are losing the power output. So it is we can delay the EBO towards the bottom dead center, because even if it is closer to the bottom dead center, the pressure inside the combustion chamber will be sufficiently to take care of the pressure gradient, and we can remove the most of the part of the exhaust gas. So if you exhaust valve opening at the lower speed, it is early, and the lower at the higher speed, it is closer to the bottom dead center. Okay, now finally is the EVC, that is exhaust valve closing. Exhaust valve closing, again the most important thing, it is not only representing the end of the exhaust stroke, but it is also indicates the end of the valve overlap period. Now EVC, that is exhaust valve opening, what does it mean? That if it is going to be delayed after the bottom dead center, I mean piston is running at low speed, so piston is now moving down during the intake stroke. Exhaust valve is still open, and that is at the atmospheric pressure. And the intake pressure, intake manifold has a lower than the atmospheric pressure, something around 0.3 or 0.4 bar. Exhaust manifold has a pressure something around 0.9 or 0.95 or even 1 bar, let us suppose. So during the intake stroke, when the exhaust valve is still open and piston is moving down, and because of the lower movement, it will create the suction, and the pressure inside the combustion chamber will be lower than the atmospheric pressure. Then what will happen? The pressure gradient will be developed between the exhaust manifold and the intake and the combustion chamber. So part of the exhaust stroke that is already present in the exhaust manifold will come back into the combustion chamber. That we do not want. So the backflow of the exhaust gas will takes place if we delay the exhaust valve opening at lower speed. So therefore, at lower speed, EVC should take place closer to the top dead center. At high speed condition, we want to remove the exhaust stroke as much as possible, so that we have we can accommodate as much as air as the fresh air mixture. So in that condition, um, we can delete the EVC, or EVC to takes place later stage. So in that way, we can conclude that exhaust valve take EVC to takes place closer to the top dead center, and at the higher speed, it should be the late EVC. With this, our discussion, okay, if you realize that all the four events, IVO, intake valve opening, exhaust valve opening, intake valve closing, or exhaust valve closing, all these four parameters, it doesn't seems like it is a fixed parameter irrespective of the engine speed, but it is a variable parameter with the speed condition. And then we can have a higher volumetric efficiency of the engine. But as far as we have discussed the valve actuation mechanism, either we have discussed two kind of the things: push rod mechanism and the overhead cam mechanism. Both, as we discuss this mechanism, it doesn't seem that we can change the IVC or we can change the valve event, because the cam and the crankshaft orientation is the fixed, lobe cam design is the fixed. How can we can change it? No, we cannot change it, whatever we have discussed till now. And so there right now is not we have some flexibility, but what I'm saying that if that's why I told you to look into the engine specification of any vehicle, you will find it out that they will write in such a way that, let us suppose Maruti Alto K10, okay, that car that has a maximum torque output of around, I think it is a 90 Newton meter, and you will find it out. The company will write or claim that 90 Newton meter torque, max torque is 90 Newton meter at the rate of 3,500 RPM. So it means the torque is increasing with the maximum torque is increasing with the engine speed. It will reach at the max at 3,500 RPM. When we will increase the RPM again, the torque will reduce. So, but if you develop some kind of the technology where instead of getting the maximum torque at a particular speed or a narrow range of the speed, if you somehow widen the range of the speed at which we can get the maximum torque output, that would be the very good condition, that we can get the maximum torque over the wide range of the speed, not at the narrow range or at a particular speed of the engine. And it is because of that fixed value of the valve event. Because the manufacturers, they are not going to fix this valve event either at the taking the consideration that engine is running at the low speed or engine is running at high speed, but they try to find it out that where most of the time the engine is going to be run, or they're trying to find it out the point where we can have very minimum losses if we are setting the valve event diagram at a particular value when engine is running at high speed or the low speed, and at that particular speed at which you are optimizing the valve event, you will get the maximum torque output, or within that range we are going to get the maximum torque output. But if you deviate from that engine speeds, your torque output will be reduced because your valve event is not optimized for the another speeds. Nowadays, some of the engine has a fixed value of valve event diagram. Okay, some of the high-end car, they have a variation, discrete variation. It's not the continuous variation. It's a discrete variation, that if engine speed will move within that range, our valve event will be like 2 or 3 set values they have. So some of the engine have a discrete variation of the valve event. Some of the engine has a fixed values, but as far as I know, still there is no any production car that those have a continuous variation of the valve event. And if we can achieve it, continuous valve event technology, do you know that what is the importance of that? Right now in the spark ignition engine, we are using the throttle to control the amount of the air, but that is throttling process. It reduces the pressure in the downstream of the throttle, and that's why we get the bigger loop of the pumping loss, that is a negative work done. But if you have a continuous variation of the valve event, there is a probability that you can remove or you can throw the throttle from the SI engine. Okay, you can remove the cam, because obviously we need to have electronic system to get the continuous variation of valve event. So we don't need a cam. That kind of the engine, we can term it as a camless engine. Camless engine. And you are controlling the valve event electronically. Okay, that may be different way how you are going to determine it or how you can control it. And if you have a camless engine, then there is a probability that you can also have a throttleless engine. So it's a camless, throttleless engine. And that is going to be a remarkable changes in the technology of the SI engine. People are trying to develop it. So that is what we are trying to see, that this is one of the areas in the SI engine where it requires to work in that areas and change the a major shift in the technology can take place if we can achieve it. Okay, so I think I should close it here, but still we have a time, and I hope you have a question. So please ask some of the doubts that you have.